Hello, everyone, and welcome to another Jakarta Tech Talk. My name is Serena, and joining us today is Kito Man, who will be presenting on the topic of GraphQL for Java developers. If you have any questions for Kito as you move through today's presentation, feel free to ask them in the chat or in the Ask a Questions tab. Without any further delay, Kito, over to you.
Okay, just bumping up my font size here. Let me go back to the proper window. This happens when you have too many windows on your machine here. Okay. So, hi, my name is Kito, and I'm going to be talking today about GraphQL. We're going to be talking about it from sort of an intro perspective. So if you're a GraphQL expert, this may not be for you, but if you've worked with it or you're familiar with it or you've heard about it, you want to learn more about it, this is a good place for you to start. So, okay, just want to look over here. Okay, cool. Let me start by just telling you a little bit about myself. I'm assuming, Serena, you guys can hear me okay.
Yes, we can hear you.
Awesome. Okay. So my name is Kito, I'm the principal consultant of Virtua, where we do training, a lot of consulting and development architecture around front-end development and back-end development. So it's sort of a full stack team, and a lot of cloud stuff as well, and some mobile. I'm a Java champion. I used to be very heavily involved in the Java community process, in some of the specs like CDI and JSF and portlets. And now that's really morphed into being involved with Jakarta EE. And I'm a member of the Jakarta EE Guardians and a Google Developer Expert in Web Technologies alumni. I just ended my time with that program recently, but it's a great program. I'm also the co-host of a podcast called the Stack Podcast, which me and three other awesome hosts, Josh Juno, Daniel Inahosa, and Ian Hlavitz, we all spend time talking about Java, enterprise development, front-end development, Angular, back-end stuff. We also usually have great guests on as well. So we have a lot of Java champions on and lots of other people in the community. So if you like podcasts, I encourage you to check that one out. I speak at lots of conferences, and I'm also working on a new product called Speaker Tracks, which is a product for frequent speakers. And we happen to be using GraphQL, so I'll just be demoing when we go through the GraphQL demo part. I'll be showing some Speaker Track stuff. But if you're a frequent speaker, you should check that out. So that's the story there. Okay, just bear with me for a second here. So I wanted to get a handle from the audience about you guys. So if you could tell me, put in the chat, sort of if you're really familiar with GraphQL, like if you've worked with it a lot, or if you're new to GraphQL, or you're just curious about it, sort of what you'd like to get out of this session today. So if you can throw that in the chat, I appreciate it. I've got a very chatty bunch here today. Okay, got a couple responses. Okay, so someone says Jen says they read about it, they're curious. Mark says new to GraphQL. Alex says new to GraphQL. Shruti says novice, just common knowledge. And Dennis says curious about GraphQL, mostly use REST and gRPC. Okay, cool. Sounds like we got a good mix there, and just the right kind of audience for this. So, okay, so what exactly is GraphQL? It is basically an alternative way to do client-server communication. We've been doing client-server communication for years. I remember doing it in the early days with Windows, and having a fat client talking to a database. That was client-server back then. But now there's lots of different approaches. We've tried different ones over the years, and REST is, of course, the most popular one. But you can just think of GraphQL as another way for your client to talk to your server. And this is a very simple example. On the left-hand side, there is the request. So the client is basically saying, I'm a hero, or give me a hero. And for that hero, just give me one name property. That's all I want back. I don't want any other data. And on the right-hand side, there is the actual data coming back with the hero element and then also the name property. So it's giving exactly what was requested. Give me the hero, give me the name. So that's basically the idea of GraphQL in a nutshell. It's basically having the client request what it wants and having the server send it back. So one of the key things is that it doesn't use REST. So GraphQL is not based on REST at all. It does usually use HTTP. So it usually uses POST requests, but it doesn't use REST, like all the REST verbs and all that kind of stuff. It was created by Facebook in 2012. Regardless of what you think of Facebook in general, they have some great technology. And GraphQL was open sourced in 2015. And in 2017, the GraphQL Foundation started. And the GraphQL Foundation's job is basically to steward GraphQL as specification and different implementations and all that kind of fun stuff. And it's actually used by lots of different companies. So if you go to graphql.org, you'll find this list of all these different companies and a lot of names that you recognize, like Lyft, Twitter. Although I don't know what they're using these days, but they were using GraphQL quite extensively. Netflix, Intuit, PayPal, and even some, sort of more mundane brands like, NBC, Wayfair, so it's not just cool tech companies. Starbucks is in there too. So why would you want to use it? So there are, of course, some benefits, and one of the benefits, and this is also one of the key differences, is that there's a single consolidated dynamic endpoint. So you don't have to remember all these different URLs to do different things as a client, and you don't have to build that out as a server developer. You basically have one endpoint, which is like the GraphQL endpoint, and then all of your requests go through that endpoint. There is this idea of subscriptions, which is really one of the best features of GraphQL, which is basically the ability to say, hey, I am interested in this data and these properties of this data, just like a normal GraphQL query, but I want to be notified when that data changes. So basically, it's a push protocol. So that's a nice feature. But for day-to-day use, one of the key benefits is that it has a defined data format. All GraphQL requests look a certain way. They're in a certain format. And then for any given application you're building, you basically define the schema for that actual application. So as opposed to REST, where you can, if you're disciplined, you can build out stuff using an open API and have, robust APIs which are well defined. But with GraphQL, you don't have that choice. Like, you have to do that. You have to have a type schema, and it has to, be integrated into your backend, and your front end has to use it. So it's a little more rigid in that respect. Whereas with REST, you can use Open API, but you don't have to. You can just write in a REST endpoint. So it's obviously quicker to get started in some ways. But you have a lot more rigor when it comes to the interface between the client and server for GraphQL. So we said that the client decided what data it wants, and this is a big benefit because a lot of times what happens with REST is that you build out an endpoint on the server side. Excuse me. I have a couple of alerts that show up even when my focus is set to silence. So turn that off. Okay, so usually, sometimes what can happen is you build out the endpoint and you want to provide all the data that the client might need, right? But there are situations where the client doesn't want all that data back. And usually what happens with the REST is you end up either creating different endpoints that have different subsets of data, or parameterizing it so that you can return different amounts of data depending on what the client wants. But with GraphQL, it's a little nicer because it's sort of built in that the client decides what it wants. So the client says, okay, I want these objects back, I want these properties, and the server's job is, of course, is to decide where to get it. but it doesn't have to worry about creating different endpoints or different parameters in order to filter the data that's returned. That's handled by the GraphQL engine itself. So it's one of the nice benefits. And because of this, it's actually well suited for backends for front ends or BFFs. So that's the idea where basically you have a special API which is designed more for the front end. And then you may have several different backend services that basically feed into that API. So you'll find companies that have like a GraphQL API, but behind it, there have dozens of microservices or even more than that. And they all feed into the GraphQL API. And of course, one of the main reasons that GraphQL was created was to address some of the drawbacks of REST. And that's some of the things I mentioned, where the endpoint decides what data is returned. The data sometimes requires several different calls to get the data back. And the format really depends on what the server is actually using, what they decide to use. So you don't have any particular rules about what the format is and that kind of stuff. So usually with REST you return JSON, but you don't have to. You can still use REST and return XML, right? But with GraphQL, it's more rigorous. You kind of have to return GraphQL, which usually is returned as JSON. So, and of course, REST doesn't have a push standard. So you can of course do push it in an application that uses REST, but there's no standard for that built into REST itself. Okay, so let's look at a demo. And this should give you an idea about sort of how things work. So I'm going to go over here. And when you work with GraphQL, there are lots of different, well, there's several different tools you can use for just basically querying stuff, playing with the endpoints. One of them, of course, is Postman. So you can use Postman. It does have GraphQL support, but it's not the best. At least last time I tried using GraphQL with it, it's not really the best tool for GraphQL. So I like this tool called Altair. So it's available as an extension like this, or also as an Electron app. But you can also use other tools. And there's also one I'll show you later, which is usually embedded inside of applications. It's a little React app. So this isn't the only one. There's other options as well. But it pays usually to have a tool that has specific GraphQL support. Okay, so what I'm going to show here, let me get rid of that. Let me get rid of this, is a very simple query. And you notice the API that we're hitting is api.github.com. And this is basically GitHub's GraphQL API. So GitHub has a very extensive GraphQL API, which is really handy for obviously querying GitHub, but also for demoing GraphQL's features. And so I'm just going to make a simple request here. And look, oh, I've got bad credentials. And as I was doing this, I was just thinking, didn't my GitHub credentials just expire? So let me just run in here and update that. And while I'm doing that, if anyone has any questions they want to throw in the chat, please feel free. Of course, I need to figure out where the GraphQL API key is. It's one of those things, you remember, didn't I get an email about that at some point in time? So okay, so if you're wondering what I'm doing here, I'm now generating a new GitHub token. Which I will then use over here. So basically, all you do with the GitHub token is you put it in a bearer here. And then you should be able to I'll have to generate a new one which has the right permissions here. Repository permissions. Okay, so what I need to do is create a classic token. All right, if you haven't done this before, this is fun stuff with the GitHub APIs. So you of course can very easily create different tokens, but they expire and you have to make sure they have the right permissions and all that kind of stuff. So all right, so let's try this again. All right, there we go. All right, so now we have the right token. And let me just check and see if there were any questions here in the chat. Okay, no questions. Okay, so thank you for bearing with me. All right, so we now have an API key, so we can actually do the demo. And what you'll see here is I've got this query. You probably had some time to look at it. Basically what I'm saying is I want all of the issues that I, from this particular repository called GitHub Keto list, or GitHub repo list, excuse me. I want to get back only the ID, name, the issues, the total count of issues, the stargazers, the number of people who started, the primary language and the name, etc. That's all I want back. So this is what I get back on the right-hand side here. Now, if I didn't want all this, like let's say I really don't care about the issues, right? I could just do this, and then I get the different amount of data back. So this is me as a developer on the front end deciding exactly what data I want to get back, which is a really powerful feature. Let me see if I can really get rid of this this alert here. This is one of those days. I do a lot of presentations. So sometimes everything goes perfectly. Sometimes it's a little bit rocky. But okay, so here we're getting all the data back. We get to pick what we want, and this is the basic idea with GraphQL, so that you can decide what you want to get back. Now, what I want to show here is what's actually going on behind the server. So we don't really care about the elements, but we do want to see the network stuff. So if I, oops. All I'm trying to collapse this section here. There we go. Okay, so if I make this request, okay, you see the request here is going to GraphQL. This is what I was saying before, how there's essentially just like one endpoint called the GraphQL endpoint usually. And I'm doing a post request. Okay, so I'm doing a post request. And this is what I'm sending. I'm sending the operation name, and this really can be whatever you want it to be. It depends on the client. And then I'm sending this string, which is the actual GraphQL query. Okay. And then I'm sending variables, which I'll talk about in a minute. And then what I get back, of course, is a JSON response, which looks like this. So this is basically just the data that you're seeing on the right-hand side. I'm on the left-hand side. So basically, it's pretty straightforward from a data perspective. You don't, if you're working with GraphQL, you don't have to use, cool GraphQL APIs to do things. You can actually just use ordinary post request responses, but obviously having the APIs, having libraries makes your life a lot easier. But this is basically what's going on. All right. So let's look at a couple other things. So another thing I want to show you is get my notes here. Okay, so I'm going to show you some basic queries here. Okay, so there's the one that we saw before, right? But this is a little bit different. So in this particular query, we actually, I don't know why I can't get rid of this variable here. It used to be easy to get rid of the variable screen here. I don't know why I can't do that. Ah, there we go. Okay. So here what I'm doing is I'm doing a query, but I'm obviously looking at a different repository. It's the prime faces repository. And I want to get the name and issues. And what's a little bit different here is that I'm sending in another parameter. So whereas before I just would say issues, right? Here I'm saying issues, and then I want to send in what's called an input object to basically parameterize the property that I'm requesting. So I'm saying I only want open issues, and I only want the first 50. And then what the API will return is a set of edges, and then which is essentially in nodes. From that, I can gather whatever properties I actually need. So a lot of APIs will provide this sort of graph-based API. You don't have to do it this way. You could return issue objects directly, but this is sort of a generic way that they do it for GitHub. So if I do a query here, let me again change my header. Here. Oops. Let me go back and grab that. Okay, so let's send this. Okay. So you see we've got the data coming back here. We've got a repository, the name of the repository, and then the edges. And for each one, we have a title. So value, attribute to be draggable and droppable, etc. So these are all the different issues coming back from the prime faces repository. Now, of course, if we change this, we would get different values. So if we change this to closed, we would get a different value back, right? And then if we change this to foo, what would happen? We get an error back. So GraphQL actually has built-in error handling, and you can see what it's saying here is that, on line 5, column 1, argument states on input object issues filters has an invalid value, foo, expected type issues state. This is where all of the strong typing and stuff comes in, because essentially the input object has properties, and it's a type. It's actually an enum type. And obviously, we were setting in the wrong value. So, and this error handling is basically what the GraphQL engine is going to be sending back by default. So what's nice is that this happens before it actually gets to your code. All right, so let's change that back. So here's another example. So here what we're doing is we're doing a search query, and search is sort of the generic API for GitHub. Essentially, it's what's behind any search that you do on the site, sort of a global search. And so we're doing the query string, and we're telling the type that we want to get back, and then how many rows. So what we do is we get this type, and then we can say, well, if the type is repository, we want these fields. We could get back a different type. And if that were the case, we could specify those fields as well. So we have the option to sort of go back and forth and specify fields depending on the type, or if we know what the type is, just specify the fields from that type. So if we do this, what we'll get back, oops. So we get, so doing a search for all GraphQL Java repos, right? And we get this list back. We have GraphQL Java, GraphQL Java Kickstart, GraphQL Code Generator, etc. So we're getting back all these properties. And again, if we didn't want all this data, we could just specify what we wanted. Now, if we did something else, like say type issue, let's see what happens now. Okay. So interestingly, we don't get anything back because I guess you can't really do a query with type issue and just look for GraphQL Java. So okay. So that's another example. And here we actually, if we just put GraphQL and don't put GraphQL Java, we do get something back. So here you see we've gotten back this particular question, this one, and it tells you what repository it is. This one. So we've got a decent amount coming back here, which is nice. And you see here we're saying node on issue because we expect it to be an issue coming back. Okay, so those are some basic queries. Let's also take a look at what things look like when you specify variables. So you've seen there's this little variables thing down here, okay? And what we can do is actually parameterize things a bit. So you see here we've got, have a query, we're calling it repos, and then we're parameterizing our query. And we're sending in a string. And this string is essentially a variable which we are sending in here. So in your client-side code, whether your client-side code is in Java or TypeScript or JavaScript or whatever, you can parameterize a particular query this way. And then in the actual query itself, this value is being used. So we want this to be circuit breaker. So we want to search for all the circuit breaker values, all the repos with circuit breaker. And again, we got to update the credentials. Okay. So we've got Rubius circuit breaker, Babel circuit breaker, Spring Cloud circuit breaker. Everybody's got a circuit breaker. There's also MicroProfile does this as well. But you'll see all of these. If we change this to something else, like, I don't know, peanuts. For some reason, I had some peanuts for a snack last night. That's what came to my brain. So see what repositories are named peanuts. So there, of course, on GitHub, many repositories called peanuts. And you can see what language they're in, et cetera, et cetera. So there we go. So that's how variables work. And obviously, when you're writing code to make GraphQL queries, it helps to be able to parameterize things for yourself. Okay, so one thing I should point out is for those variables is when we see the request, you'll notice before when we saw the request, there was this variable section. And here's the data. I'm sorry, here's the payload, and then here's variables down here. So what happens is the query is sent, and then the variables are sent separately. Okay, so it does change actually what's sent in the request. So another thing I want to talk about are fragments. So you can actually have different fragments in your GraphQL query. I'll finally get rid of this once and for all. This example here, you saw this earlier where we did a query and then we basically said, okay, if it's a repository, do this. These are the properties we want. You can actually pull things out into fragments. This is sort of an inline fragment, but you can actually do it this way where you say, okay, this is a fragment and I want to be able to reuse this section. So anytime that I am working with a repository, I want to grab these properties. And then what you can do is reuse it this way. So you can see here we've got repo fields, which we could then reuse in different places. So this should look pretty much, let's see the credentials problem. Don't ask me why it resets this each time. Okay. So this is still coming back with the properties that are specified in repo fields. So it's pretty handy there. So those are fragments, just allow you to sort of build up your queries out of different pieces, which is nice. In terms of what it actually looks like, if we look at the request, take a look here, and you see, in terms of the actual request, what we see is the search, and then if you go down further, you see edges node. So you don't really see the fragment on the server side. It's more of a client side thing. Okay. All right. So the last thing I want to show, actually, there's a couple more things. So one other thing that is important to understand are directives. So directives are an extension point to GraphQL. So basically, it's just a way to do different things over and above what's built in. There's a couple built-in directives to sort of give you an idea about how it works. So here I have a variable that I'm using called show language, and I'm passing that in. And then what I'm doing is if show language is true, and only if it's true, I want to include the name property. So where am I listed now? Okay, so we're just looking for any repository with GraphQL in it, and only if show language is true do we want to show the language, right? So the language here is Go, language here is TypeScript, etc. So if I change this to false, I will then see that there is no language included. Okay, so this is one directive, which is if, or include, I should say. And then another directive is skip, which is the same idea. You can skip a section based on some condition. So there's two very simple directives. But what you find is that different GraphQL implementations, and this would be on the server side, will have different directives that they may support. And you'll also find that in situations where you're using a GraphQL service, we'll talk about some of those later, they may have different directives as well. So it's basically just an extension point. So we spent all this time talking about GraphQL queries, and it's called GraphQL, right? But in a real application, you probably are going to want to do something else, right? You're probably going to want to update data as well. That's where mutations come in. So this is a mutation, and a mutation looks surprisingly similar to a query, right? But you'll see that we basically are usually, and almost in most cases, you are actually sending in some input objects, because obviously with a mutation, you're sending in data you want to persist. So you need to be able to send that data in, and you send it in with an input object. So here we're saying we want to create a new issue. And this is the repository ID. So this is the ID of the repository you want to create an issue for. This is the title, and there's the body. So what I'm going to do is I'm going to change the title is to say hello. Hello from Jakarta EU Tech Talks is what it's going to be. And I will again update this. Okay. And interestingly, what do we get back here? What we get back is this data that's requested here. So when you do a mutation, you usually do get the object back that you create. And from there, of course, you can specify what properties you care about. Okay. And of course, I could say I don't care about these properties and then not get them back. But usually it's useful to get the object back that you created. And this is what we're seeing here. This is the data we get back. Now, interestingly, there's this other stuff here. So GraphQL has this extensions option where you can basically put in whatever you want. And GitHub has said, okay, this has been deprecated. You should use the next global ID from the data payload as opposed to this. Okay. So you can send in whatever you want in here for extensions. Sometimes you'll find this is useful for additional error handling, things like this. So this is how it works. And what's nice is that you can actually see what happened. So this is that repo, that ID that I put in here. This is a demo I use in a different project, a different talk, and there's my issue. So I created this hello from Jakarta UTech Talks issue, and there's a demo. There's the data. Okay. So we can see it obviously worked, and that's how mutations work. Okay, so that's the quick sort of overview of, from a client perspective, what GraphQL is, how you make queries, all that kind of stuff. So let's look at a little bit more detail. Oops. So let's talk a little bit about schemas. So I said before that with GraphQL, you have a schema, you have a contract between the client and the server. So the contract here it's type saved, and as you saw, the client can only request data defined in the schema. Actually, we didn't show what happens if you request additional data, but you would see that. And versioning can be handled through deprecation. So unlike REST, where usually you have version 1, version 2 of the endpoints, etc., with GraphQL you handle it with just using a deprecation flag for different properties you don't want to support anymore. And of course, eventually you remove them. And I think that's sort of a good thing and a bad thing. It's a little bit easier to work with, but then again, it's always hard to get people to remove deprecated code. So it's pros and cons. Okay, so let's look at a demo of a schema. And what I've got here is the GraphQL schema from GitHub, which is the same one we just looked at. I'm assuming this is big enough. If anyone can't see this, let me know, and I'll bump up the size a little bit. So this is the GitHub schema, and you notice it is, let's see, really, really long, right? So this is actually an older version, but it's like 40,000 lines. So it's a really big schema. Obviously, there's a lot of stuff you can do with GitHub. But obviously, we're not going to go through it all. So let me show a couple things here. So first, each schema is going to have sort of a top-level query. Okay. And that's what we have here. And you can see we've got like the code of conduct. We've got all the different properties you might expect. And there's also this documentation here. So this is a comment. And this is useful because this is also how you document your API. So sort of like with OpenAPI, you might provide documentation either separately in an OpenAPI document or via annotations. Same idea here. So the documentation describes what's in the property, what's in the schema, and the client can then use that to figure out what to do. So this is the top-level query, which has lots of stuff in here. We were looking at the issues query, so let's find that. Actually, we're looking at a couple things. We're looking at search, and actually we're looking at repository. So this is the repository query. It had the name and the owner. Okay, and this returns a repository object. And the types are pretty similar to what you might expect. So you can have different types, which is sort of like an interface. And then you can also implement things which are actual interfaces. So it's sort of like the type is like a concrete type, and then the interface is something you can, implement in different types. But the main difference is that obviously there's no other, there's no other properties or anything. It's just the types that are in here. It's just essentially saying these are the properties and these are the types that they require. So repository implements node, package owner, all these different things. Okay. And these are all the different properties that it can have. And you see there's also primitive types too. So Boolean is a primitive type. Okay. Int is a primitive type. And a lot of these other ones are not. So of course there's code of conduct. If we look at this, we will see it is a node, and it has a body, a key, name, resource path, etc. Okay. And what I should take a look at here, this is one of those days where every single little thing's done. Let me just stop the phone call here. And that phone rings like, once every couple of days. So, we're looking at issues before. So let me find issue. And here we see it's got a whole bunch of interfaces it implements. Okay, and then it's got authors, URI, etc. And when you see this bang here, it means it's required. So if anyone is trying to get data back, they need to request that. There's one other thing I want to show here, which is there's a couple different things here. So we talked about there's basic types like int and boolean. There also are enums. Okay, so instead of type, you say enum, and this is where you can specify a normal enum like you're used to having in any language. So this one has an enum for this. Let's find a more interesting one. There's also unions, as you can see here. And member order field, so created at, login, etc. So the enums are pretty much like you would expect. And you saw one before where we were specifying the type of node that we wanted back. So that should give you an idea there. And this is actually another one. Another good one is repository permission. So this one has more that you might expect, like admin, maintain, read, triage, etc. Okay. And also, so that's basically, how schemas look in general. I should also show you the mutation. So we saw the top-level query object. There's also a top-level mutation, which is the same sort of deal, but almost every mutation is going to take an input object. And an input object is just a special type that only has input fields. And if we look at this, we'll see that it just has different properties that you specify. So when you add a comment, you need to specify the body. You don't have to specify these things, or the client mutation ID, but you do need to specify the subject ID. Okay. So that's basically how mutations work. It just looks very much like a query, except that you are essentially usually taking in an input object and returning some type. Okay. So that's basically how schemas work. So basically, a GraphQL API endpoint will expose a schema, which tells the client how to actually interact with that endpoint. That's basically the idea. The other thing that schemas give you is built-in documentation. So we go over here. So for this endpoint, I didn't click on this before, but there's this little docs thing. Okay, and if I refresh, this will give me documentation for all the GitHub endpoints, or the GitHub queries and mutations, I should say. So this has all the ones where we just looked at. So we saw query, and we saw all of these, and you see these are the comments that we have here. And then, of course, you can go through, look at the different objects just like we did before. Okay. So because we have that defined format, we can then write tooling to make our lives easier. The other thing that we get from the schema is the ability to do code completion in the query. So I didn't show this before, but I could have just gone like this and try and find what property to throw in here. I can get URL, I can get resource path, I can get other things as well. And this goes for any object I put in here. I can then, get it, and then I can, well, I just did author, but I can do something else here. Editor. Okay. And decide I wanted to get the login for all the editors. And so having the schema makes it really easy for the client, for you to generate queries, and also really easy to document what's going on as well, which is nice. Okay, so I made that change, and then when I get back are additional properties as well. There's no editor for this, so nothing new really came back. But we got the URL and the resource path. So that's another benefit of having the schemas. All right, so let me go back over here. So there's a few different design approaches when it comes to building out schemas. One is the schema first approach, which is basically where you work on building out a document like the one I just showed you, and you build it out usually by hand with some good tooling. And then from that, you can generate code. You can generate models for front end and back end, and in pretty much any language you want. But of course, with Java or TypeScript or JavaScript, etc. And then you work from that. And that approach is really good when you are working out what the schema is with like two different teams. So you can basically hammer out what the schema is like and put it in a different repo and then generate code from that. And that works out really well in that scenario. Another common scenario is code first, which is where you write the backend code and the backend code generates the schema for you. And that's often what you see in a lot of projects because it's a little bit easier to get started. You can just start writing code and generate the schema, so it's a little bit less work. You still may end up generating the models on the front end from the schema, depending on how you do things. But it gives you sort of a more code-oriented approach to things. The main idea is just to decide what you're doing up front based on your team and your needs, and sort of stick with it. It's going to be hard to switch later on. The other thing is that a lot of tools don't support schema first. So if you want schema first, you need to, that will affect like what libraries you can use on the back end and the front end. Okay. So another piece are subscriptions. Subscriptions let you push data from the client to the server. And what's nice about them is that they're transport independent, meaning that the way you write the client and the server doesn't depend on how they actually interact over the wire. So WebSocket is the most common protocol, but there are other ones. There's lots of different messaging protocols. There's even MQTT, which is popular for IoT. So it's nice because you can kind of build your application and then pick the transport mechanism that works best. And of course, the caveat there is that WebSocket is almost universally supported, whereas the other ones are less common. So obviously, if you need a particular transport, that may again impact the library that you use. Okay, so unfortunately I don't have a good demo for subscriptions, but it's definitely one of the cooler features of GraphQL. Okay, so we're running a little short on time, so I will try and run through this quickly. So federation is a newer aspect of GraphQL. You'll see some products and tools talk about it. But basically, it's the idea that you can have a federated GraphQL gateway that basically combines other smaller GraphQL API endpoints. So sort of like an evolution of the BFF into from sort of an ad hoc system of having sort of organically building an API from different endpoints to more of a structured way of doing it. And basically what's nice about that is that it does allow you to basically look at different GraphQL APIs that you have in your environment and then stitch them together into a unified GraphQL API. So if you run across that, that's one of the benefits. And Netflix did this, so there's actually a great write-up about Netflix's process, which I believe is in the resources for this. So. Okay, so implementations. I'm going to do a really, really quick demo, just so you see some actual code. And what I will tell you is that there's pretty much universal support for GraphQL on the client side. Apollo is the most popular client library. Apollo is a company that is basically the GraphQL company. So they've got a really powerful GraphQL client, sort of a React-first client, but they do have support for other technologies as well. Apollo Elements is what I like. It's web components for GraphQL, and you can use it with any library you want. But obviously web components work best, and there's lots of other ones. On the server side, for the Java world, there's GraphQL Java Tools, which is sort of a lower level library, which you can integrate in any server-side application. Using REST or servlets or whatever. So it's sort of, it's a handy tool. It's really good for doing schema first support, which is nice. There's also DGS framework, which is a powerful framework from Netflix. And it's more of a Spring Boot oriented framework, but that's available as well. There's micro profile GraphQL, and that one supports Federation, I will say. There's micro profile GraphQL, which is what I'll be looking at today. And that is basically just an implementation of GraphQL that works on top of Jakarta EE and micro profile using on top of Jakarta REST. Well, not really Jakarta REST, but on top of all the other micro profile stuff, CDI, etc. So that's a nice choice. Spring also has GraphQL support as well. So this is a relatively new project, but it does give you GraphQL support in Spring. And on the JavaScript side, as I mentioned, there's lots of different choices, lots of different libraries. So let's do a really, really quick demo in the amount of time we have left. So I have spun up, I've got a little application here. So we've got the Speaker Tracks app, we're working on it. It's built using GraphQL and Quarkus on the back end. Quarkus is a microprofile implementation, among other things. And also on the front end, it uses TypeScript and web components. So, so that application looks like this. On the front end, it looks like this. Okay. So we've got a, just want to make sure, there you guys are, okay. But I lost my tab for a second there. So basically this particular part of the application lets you see a speaker profile, okay. So speaker profile has information like who the person is, their books, and sessions that they have, and then you can filter sessions and things like that, okay. So you can do all this. So from a GraphQL perspective, what we want to do is provide an API which lets you then query for a speaker profile and get that data back. Okay. What we've got here is the GraphQL API. Okay. So I'm going to send this query to get the profile. And here's that profile back. And on the right-hand side, you see the speaker profile object, the ID, the bio, the sessions, all the stuff that's being displayed there. Okay. So all this is right here. And basically, the way this works is inside of my little Quarkus app here, I've got this speaker profile API. Okay. So Speaker Profile API is just a normal class. It uses this annotation GraphQL API. Okay. We're using CDI to inject like this. This is an experimental feature of the GraphQL API, but we inject a context on this session factory we're injecting. We're using the Hibernate reactive bindings. So you can basically use Hibernate in a reactive manner. And then we have a query. So this is our query. This is the description that will be displayed in the schema. Okay. And this is the getting speaker profile. And then this is the ID that's returned, or that needs to be sent in. We're returning a uni, which is an object that's returned by the Hibernate Reactive API. It's supported by the Quarkus implementation of microprofile GraphQL. But we could just return a normal speaker profile here. It would work just fine. It would just be blocking. That's the only difference. And then we return find. This find is just a helper method that basically does a database call to find something by ID. So very straightforward there. And what's happening here is there's also other methods here. So there's the get speaker profile, right, which returns speaker profile instance. But also we have the speaker object itself, the headshot, all these other properties. And these can actually be handled by different methods. So if you use this source annotation, you basically say, hey, for any property of this type, you can grab it from here. Any property of this name and type. So we know if there's a speaker, it's going to grab it from this method. If there's a headshot, it's going to grab it from this method. So even though the initial entry point is this query, it'll be making other calls as well. Okay. And what's nice about this is that if the client doesn't request all those other properties, these calls will never be made, right? So we end up with some performance gains as well. So this is a very, very simple example where you basically just use the right microprofile GraphQL annotations, and magically you have a query. Now, what we can also do is look at the results here. So one of the nice things about Quarkus is there's this little dev mode here, right? So we can look at the Quarkus dev mode, and then it actually has the ability here to look at the GraphQL schema. So here's my schema. And this is all created from the Java code, okay? And so, for example, this type person here, this is here. Okay. This is a normal entity, nothing special going on here, right? So all of the entities are just normal JPA entities. Okay, so that's the schema. And I also mentioned a lot of, there's also other options for interacting with your API. So this is the GraphQL UI, which is built, I forgot the name of the project, but there's a little React app, which is really easy to just put into any GraphQL server. And this is it. So you can also look at stuff this way. So, and it has those same sort of features as Altair. It's not quite as powerful, but this will let you do things like this. So I want sessions, and I want the description of every session. So I can do this, and then get my profile back. Okay. So again, this gives me each session coming back. And as you might imagine, there is, again, the documentation as well. Okay. So we can look at the root query, we can get back the speaker profile, get back a session, etc. So, and all this is generated by code because microprofile GraphQL works code first. There is no schema first approach for it right now. So that's basically the idea. There's also the ability to write mutations as well. If I look at my speaker profile API, there's a mutation for updating speaker profile as well. Okay, so I can make changes to it. And then there are also different endpoints or different APIs for different properties. So, you know, all that kind of fun stuff. Okay, so, and then on the client side, basically this is TypeScript. This is the method that loads the profile. And then if you look in here, there's a superclass. If you're not familiar with TypeScript, it looks sort of like JavaScript and Java combined. But essentially what's happening here is we are making a call to this fetch method here. That's the real fetch method, excuse me. Actually, this is a slightly different version of this API than I expected to have, which is fun in my life. Okay, so what's happening is, if I look at the actual code that I wanted, okay, so this is what it's supposed to look like. This is load profile, and what it's doing is calling this helper method, query speaker profile, which is just a utility method, which basically grabs a query, does a query for a particular speaker ID. That query calls this controller, and the controller is actually it's a reactive controller from the Apollo GraphQL Elements project. So it's basically a GraphQL wrapper on top of custom elements. So it's basically an easy way for us to make GraphQL queries. So we're doing execute query. We're passing in a variable. We talked about variables before. And then we get this data back. And you notice we actually are returning the type. So because we specified up here, where were we? That we wanted, this profile is of the type that we want. And here we're specifying this type speaker profile. We're actually getting a typed object back. So we're making GraphQL query, but getting the typed object back. We've actually generated models from the schema returned by the backend on TypeScript. So this is from the Hibernate entity. We basically end up with something like this, generated using TypeScript generator. Okay. So basically, we've been able to do code first usage of microprofile GraphQL, generate schema. From that schema, generate TypeScript entities, and then use Apollo-based APIs to make queries on top of GraphQL. So that's essentially how it works. So that's my quick and dirty demo. I'm now 4 minutes over. So let me just wrap up here. All right, let me get back to the right window. Okay. Okay, I managed to jump to the end of the slideshow here. Okay. Okay, so I've talked about how great GraphQL is, and so the question would be, well, why would you not use it? Well, nothing's perfect. You may not want all the additional overhead that's involved. You may not want the type schemas, having to define a contract, all that kind of fun stuff. So it really depends on how complicated your system is. If it's really trivial, then you just write a REST endpoint. But if there is a lot of data involved, especially complicated data coming back, then GraphQL might be a good option. If it's really a write-only service or a mostly write service, GraphQL may not really be what you need. And of course, there's a lot more magic going on. There's a lot more processing that the engine does and everything. So you may not really want it to do all those different things. And some people don't like too much magic. So if that's your case, then it may not be the best choice for you. And of course, REST has some benefits. It's really easy to use. It's super popular. And it's, you don't really have to do any training or anything on it. So there are certainly benefits for REST in and of itself. Okay, so a few resources. So there is, these are, we'll put in the notes a link, but these are different places you can look at to learn more. There's a GraphQL site. This article on schema first approach is pretty handy to get an idea about the pros and cons. And then there's some other links to some of the other things I've talked about here. The code that I just showed you is not available on GitHub, but this microprofile GraphQL example is, and that's really handy for just playing with microprofile GraphQL. All right, so what I'm going to do right now is in the chat, I'm going to put the link where you can find out more about this talk. And Serena, I don't know if we have time for questions or if we just need to wrap up. So. Hello. Lou? Okay. Well, if anyone has any questions, you can put them in the chat. I guess we're still here for a minute. But thank you so much for coming. And you can check me out at Keto99 on Twitter, and at keto99.mastodon.social on Mastodon. And you can find me at ketoman.com and virtua.tech.
Keto, do you hear me?
Oh, now I can hear you. Yes.
Yes, I was so we did have one question in the chat.
Okay.
And it says, is it support pagination?
Oh, yes. The answer is yes. It does support pagination. And
okay.
There's different ways to support it, but yes, it is supported.
Okay, perfect. So yeah, that was the only question that we had there. So I just wanted to say thank you so much for the excellent presentation today. And if we are looking to book some more Jakarta Tech Talks at the end of the year, so please feel free to fill out the form that I'm going to link in the chat if you are interested to participating in hosting a webinar with us. Thank you again so much, Keto, and everyone. Have yourself a wonderful day.
Thank you.
Thank you. Bye.
Bye-bye.